I want to introduce you to Fermat's principle of stationary time, often called Fermat's principle of least time. The idea is that if you have a couple of points in space, then of all the possible paths that light could take, getting from one point to the other, the one it actually takes is the one of least time. And if we're dealing with a vacuum or some medium of uniform density, then that's also the least distance. So Fermat's principle explains why light travels in straight lines. Well, maybe you didn't need that explaining, but it's more interesting than that. If we have a mirror, something like so, then according to Fermat's principle, the path of least time that intersects with the mirror is the one in which the angles of incidence and reflection are the same. And a nice way to prove that is by considering the reflection of the receiving point in the plane itself. So we're imagining that it's down here in equal distance, and just imagine continuing that line on. Now that line has the same length as that line, and the incidence line together with the imagined line are a straight line, and therefore that's the shortest distance between the original point and the image point, and that's the same as the distance via the mirror from the original point and the receiving point. Any other line from the source to the receiver, say that one, has a greater distance, as you can see by continuing the imaginary line, and you can see that that bent line has greater distance than the straight line. So Fermat's principle explains two things: not only why light goes in straight lines, but why the angle of incidence and angle of reflection from a mirror are the same. We can do even more. Let's imagine that we have a block of glass, some kind of high refractive index material, and consider the path from a point like that one to a point to space downwards. Now, if the glass wasn't there, then the straight line path would be the least distance path and the least time path. But because light goes slower inside the material, the least time path is one that's spending less time in the slow high index material. And so the least time path is the one that is bent like so. Another interesting and important fact that we can prove using the principle of least time is that if we have some arbitrary optical system which we don't understand, or at least don't know about, and we imagine a ray coming in and then coming out, and we know that that will be following the path of least time, and therefore if we reverse everything so that the ray now goes in the way that it came out, we know that it will come out the way it went in, because reversing the direction doesn't change the time. So if going one way it's a path of least time, then going the other way it's a path of least time. This is known as the principle of reciprocity and is really useful in studying optical systems. It's immediately obvious from the principle of least time. It's not obvious how you would prove it any other way. Finally, in one of the problems for this week on Fermat's principle, you'll show that if you have a mirror that's moving downwards at relativistic speeds, so half the speed of light or something like that, then when light is incident on it, it reflects at an angle that's different to the angle of incidence. So for a moving mirror, the angle of incidence and the angle of reflection are not the same. This can be proven fairly straightforwardly, as you will do,